I think that I'm kind of an AI agents hater, more of a hype hater, because everybody's talking about it, but nobody's really talking about what are AI agents. For real agents, you do need a planner. Hi everybody, I'm Yuval, and you're listening to YAAP podcast from AI21. In this episode of YAAP, we're going to dive deep into the concept of AI planning and how are AI agents without planning. Hint, do not exist. And today I'm speaking with Nitzan, an Algo tech lead here at AI21 as well. Hi Nitzan.
Hi Yuval, thanks for having me here. Nice place. It's a new one.
Yeah, you're the first one in this setting, so I'm hoping that you're enjoying here.
I like the look, okay.
So I gave you a small introduction, but tell me the elevator pitch about who is Nitzan and what are you here?
All right, so I'm Nitzan. I'm working in the deep learning environment for 5 years. Previously, I worked in computer vision style of work, and now I'm in natural language processing. And specifically in the last year, I'm dealing with AI agents, planning, reinforcement learning, all this jazz.
Yeah, all this jazz, and really AI agents is now the hype, right? So let's dive into it and maybe start with the most basic but confusing question. What is an AI agent?
Yeah, good question. Really overloaded term that integrates a lot of hype around it. So I usually want to distinguish between two families. One is the chains or workflows that we see all around. This is just a serial code that solves specific use case. Its building blocks are LLMs and RAG, but it's fixed execution graph for every run. And it's really nice. We see enterprises use it in production, and it solves a use case really well. The second family is the AI agents, which are more autonomous solution that gets a goal and the tools, and it does something we are not sure dynamic execution graph to solve this task.
So you mentioned two kinds. One is chaining, which kind of sounds like prompt chaining, but not just prompts, right? And the other is like an autonomous system.
Yeah, that's right. But both of them are also continuing tools, which can be RAG, web search, calling calculator. We also know those tools right now as MCPs, which are the way of exposing those tools as microservices.
But in your opinion, both of those things are agents or?
So we're going to focus on the other one, the more autonomous creature. This is an emerging technology that getting a lot of hype and for good reason.
Okay, so if it's getting a lot of hype and good reason, what's the current state now? What's happening? What is the prominent agent that we see now?
All right. So no matter what code framework you use, probably when you typing your create agent method, you get a React agent. React agent is the basic framework for agents, which consists of a basic loop. This is a prompt you give to the model and states how to act upon instruction. So you get an instruction and the model moves between three states. The first state is the reasoning, like chain of thought on the prompt to understand what to do. The second state is taking an action, which is outputting a function call to do some action with some tool. And the third state is the observation. We get the result of the tool and continue to the next loop, which is I got new information, I have the initial goal, how do I continue to solve the task?
Okay, and React, not to be confused with the front-end framework, right?
Yeah, this is an abbreviation of the original paper, which is reasoning and acting.
Okay, so in short, React. Yeah. And you're saying this is the most prominent method. Can you maybe guess how much? Like, are there any other agents, or this is like the main thing?
So this is the main thing. Wherever you use MCPs or stuff like this, you see it. You see that the model thinks between taking an action. You see the action. You see the outputs. This is the more than 90% of the use cases use it.
Okay, so it sounds kind of perfect, right? If almost everybody uses that, it's really simple, right? Just like think, look what happens, then act, get some feedback. So What's the problem? Why not?
Okay, so you're right. It's super simple, really nice and simple approach. But we do see some problems and maybe drawbacks here in this framework, and this is also going to be the segue for the advancements in this area. So let's, for example, take the instruction, the goal of doing a competitive analysis. I have, for example, I want to compare the top 3 companies in the automotive industry. So how would agent would solve it? Probably it would do some search, which are the relevant companies. Then it will do for each company a research, deep dive research to understand the current state of the company. And lastly, it's gonna output some table for comparison or other format that the user asked for. So one thing we can think about it is that we don't know what React gonna do. It's a dynamic execution. We can't reflect to the user before we start all this research what we're gonna do. And we see, for example, in all those deep research products like OpenAI, Gemini, Perplexity, they show to the user before they start what they're going to do.
You're kind of like asking a permission or something.
Yeah, and this is really nice, and it's not a property that React had.
Because what you said, React, essentially, I'm giving a task, and then it goes into this loop by itself, and like, oh, I'm printing the things on the way, but like you sit back and sometime I will give you the answer.
Yeah, it's unpredictable. And if you want to verify beforehand with the user, you just can't. So this can be one drawbacks, which relate more to the UI of the product, which is also emerging trend.
Sounds like you can maybe do some sort of variation to React to add some sort of a human in the loop kind of thing. Is this something that happens, something that you see?
So it's true. You do like initial phase of some planning or outlining what you're going to do and then verifying with the user, and then you start. But you need to stick also to this plan. You don't, you can just say stuff and go unpredictable afterwards. So this is one drawback. The second drawback is that React is serial execution approach. So in our previous example, we have 5 steps, 1 for searching, 3 for deep research for each company, and 1 for the output. So we could think that the research per company can be paralleled, right? Because they are independent of each other.
There's no reason to do them one by one unless you're a human, and that's
and we can reduce latency. So it's again a property that React doesn't have, and probably we want in our agent if those are kind of the tasks we wanna solve. The third thing is that we see that React is failing or struggling with very complex tasks like math or coding, and we believe because it lack of a breakdown mechanism. So if React encounter a complex task, so it just try to solve it in a greedy way and doesn't do a breakdown to solve the task in more human-like way.
A methodically way, I would say. Okay, so just to make sure that I understand, you're talking about React as a framework. There is an LLM in its core. So it doesn't really matter which LLM is it. I can use essentially anyone.
So that's true. React is a prompt. You prompt the model to do whatever you want. It works in any model. But the concept of using one model is, again, a property of React. It uses the same model to prompt it again and again. And when we do such breakdown, as I mentioned, I can also delegate some of the work or the sub-goals to other models. And this is really nice property because I can, for example, have models with different cost-quality trade-offs or LLMs that are better at specific tasks. And those concept of multi-agents framework are very suitable to when you do a breakdown.
So you mentioned latency, you mentioned the multi-models, you mentioned the, let's call it either observability or the dynamic kind of way of execution. Mm-hmm. These are all limitations of React. Mm-hmm. How do you solve that?
Yeah, so this is a great motivation for introducing the planning concept, which is basically an initial phase we do before we start working and to think about the problem and outline the steps we're going to do before we start. So each drawback would be solved with planning. Aha moment.
Tell me how.
Yeah. So let's take the parallelism issue. When you do such planning, you can understand which steps dependent on each other, and then you can manage your execution before you start to gain this latency reduction.
So in your example, I can make a plan of the 5 steps that you mentioned. This will be just a plan. And then ideally, I can understand that the 3 middle steps are parallel.
Yeah. In a happy flow, that's what would happen. So this is one thing. The next thing we said is the UI thing. I can reflect to the user the plan before I start working on it, verify, do some negotiation, and then start. Also a nice property. The third thing is the breakdown that we see that those kind of approaches helps and improve the quality in complex tasks. And we also gain the concept of delegation to other models because I can break down my initial goal to sub-goals, and then each sub-goal can go to other sub-agent or stuff like this.
Yeah, so we have the planner. I would say this is essentially the breakdown, right, of the tasks, and then just assigning them to whatever model, parallel, not parallel. You can have human in the loop in the middle. So this is like the big agent that we all dream about.
Yeah, that's true. When we speak about the planning mechanism, we usually split it to 2 components. One is the planner. This is the component that's responsible for getting the instruction and the tools and output the first breakdown outline. And the next component is the execution engine, which gets this plan and then responsible for how to orchestrate all the tasks and the tools to stick to the plan and emits a result.
So you would say that at the core of every agent, there is a planner and an execution agent that works tandem?
Yeah, that's true. There is a coupling between those 2 components. And I think there's a lot of design choices along the way that you need to choose between. But I think the main one is how they connect those 2 components, which is what is a plan? So one component needs to output a plan and the other component, the execution graph, needs to get a plan. So how does this plan look like? So there are 2 main approaches in the industry. One is the free text approach. It's just like a shopping list. I have those tasks in a human readable manner, which is pretty simple. And
it's kind of like what you said in the example, right? You have to do competitive analysis of those 3 companies. Step 1, research. Step 2, 3, 4,
deep dive research.
Deep dive research each one of them. Step 5, summarize whatever.
Yeah, that's true. So the free text approach would just state them in a user-friendly way. Simple, but it's a bit lack of expressiveness, like the other approach I'm gonna introduce.
What does it mean, lack of expressiveness?
So it's limited. You can just say what you can do with human readable text, and it lacks of some operators that you may need or dependency between steps that might help you do the execution better. So this is the first approach. The second approach is let's just express a plan as a code. Why is it good? Because we all know code. It has a lot of expressiveness because of those loops, conditions, other functions I can use. And also we have like a quality benefit because LLM's really good at writing code. They trained on it. So we also have the model to be good at this task.
Yeah, and it's kind of funny to think about that. For us, it's very natural to think about plans in free text, but in the end, computers or softwares are running these tasks, right?
Yeah.
So they're not used to like the entire thing of taking free text and translate it into code. It's a whole subject.
Yeah. But there is an issue with code, right? It's a bit weird to take code that the model generate and just run it, right? You need to approve it with your security manager of the company, like cybersecurity issues that you don't want to run a code that could be malicious.
Yeah. So how do you mitigate that?
So those kind of stuff usually use some sandboxes to run this execution code, or you can static analysis your code before you run it. So you just verify there are no imports, that you know all those functions, and you're sure this is the code does what you want it to do.
You mentioned both free text and code-based planners, right? Can you maybe give examples from the industry?
Yeah, sure. So for the free text plans, we see it, for example, in Magentic 1 architecture by Autogen. It's a code framework for agents by Microsoft, which they state their planner just emits this shopping list tasks in a human-readable format. And for the code-based planners, we see, for example, the small agents by Hugging Face. This is an architecture based on a paper called Code Agent, which it's kind of evolution of React, just with code. You don't just output a specific tool call, you output a code that use a couple of tools.
So in this case, I'm sorry for the maybe weird question, why not all React users go to use small agents instead?
Yeah, so it's a bit more complex because, for example, as I mentioned, the small agents architecture has a security issue because of running the code. So they use a sandbox service to run this code. And also, I think it's a popularity thing. React is very popular. We're going to see a transition movement, I guess, in the upcoming years.
Maybe.
I believe that for simple tasks, it's a really good solution. And if your use case is simple enough, it's going to be okay. And I think it's a good distribution. Like 90% of the use cases are kind of simple.
We talked about the industry. We talked about the models out there. But if I want to use a planner, like you actually trained them, right, from scratch. How?
Okay, so you can avoid the concept of training by just prompting an LLM to output a planner in your desired format, which is a good way. It's probably gonna bring the value of planning. But if you want to push forward the quality even more, you probably want to enhance these components of planner by some training. So the training of planner is very similar to the reinforcement learning settings. You have the planner, which is the policy generator. You have the tools, which are the actions, and you have the environment that you get some feedback. And lastly, you get a reward whether you were correct or not in the entire run. So if we take these settings, we can just generate a plan, run it, get reward at the end, and then backpropagate gradients till the planner and train it. So the next iteration, the planner would be better, and so on to continue with those simulations.
You mean based on like the way you create these simulations is that you have some sort of tasks that you already know what's happening there, or do you have a verifiable ways to say this is good, this is bad?
Yeah, it was between the lines. You need to have a data set that you have these instructions, and you need to have the final answer so you can verify in some way. And this way you can train in this setup. A more easy or simple way to do it is via a rejection sampling approach, which means we can generate multiple plans, then run them through the execution graph, see which plans gave the correct result, and then we can take this pair and move it to a supervised data set of instruction and the good plan that solved it.
Are there any public data sets that someone can take as like a start or a toy example if they want to try and train a planner, or everything is homemade?
Okay, so because we said that the planning format is Wild West and we don't have a standard there, we don't have this benchmark out there. We do if we start from the code approach. Most of the LLMs gonna start with a good starting point that would output good programs or plans at the beginning, and this will start to the training in a good position.
You had to actually build this type of data set by yourself as well.
Yeah, you need to craft it based on your tasks and your planner and execution engine you crafted.
Okay, and maybe like I'm thinking about DeepSeek every time I'm hearing those kind of RL or something like that. Is it the same? Is it not the same? Is
Yeah.
it kind of?
Very similar concept, both in DeepSeek R1 and OpenAI O3-4 families. Allegedly, we're not sure what they did there, but for what we know, it's the same. We have an instruction, we have the chain of thought that those models output, and it's kind of the same. You just give the model to output the chain of thought and then the final answer, and you punish on the final answer, and the model learns how to do this chain of thought effectively.
But the DeepSeek model is a reasoning model, and we're talking about planners. Can you maybe give me what's the difference between them?
Yeah, so the planner settings is more complex. We have those two components. First, I'm generating the plan, and then the execution is kind of, I want to say, deterministic component, but it's not. It also has non-deterministic functions and tools. But it's kind of the same that the DeepSeek model or equivalent generates this chain of thought and then the final answer. Though you don't ever hear the execution engine, but you do have here some gibbering of the model.
So let's put the reasoning models aside. We're here in planning. You mentioned, well, you can just maybe take a model, use it as like what we call LLM as a planner, right? This is you're just a planner, and that's all you're doing. The world greatest planner, blah 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 blah. And then you said, well, we can instead go deeper, just take a model and train it from scratch. And you've mentioned that you're doing a lot of simulations.
Mm-hmm.
What's the next phase? Like, that's all there is? Simulations and we have a planner?
Yeah, it would bring you to the extra mile and gonna improve the planner dramatically.
Okay. And in this case, we're saying that planner is better than React in the sense that it breaks down tasks, but also that it gives us more flexibility, if I remember correctly.
Yeah, that's true. So the execution engine can utilize the concept of plan and do this magic of running in parallel specific tasks, and also manage this orchestration of calling all those tools.
Yeah. And if we say, for example, there is a problem in the middle, at the end, or something like that?
Yeah, that's a good question, because we kind of stated that planning gonna solve all your problems, but it doesn't work in real life.
You should really be a motivational speaker.
Yeah,
Anybody, like a Hallmark cards, maybe.
Yeah, we are leading to a specific...
Planning is the best, but it's not.
Yeah, utopia. But it doesn't work because when you plan ahead and then you start running it, you encounter the environment during the run, and you see that stuff you planned didn't go well, whether it's some tool failed or you didn't get the information you intended to get, and then we need some fallback mechanism. We need to understand that something bad happened, and then to understand how to continue the run based on what we just collected. So usually the most classic way is to fall back to a replanning mechanism, which means we have a component that gets all the steps I made, all the information I collected, and what are the next steps I want to do to solve the initial goal. And if you think about it, the planner is a specific case of replanner. What does it mean?
You don't have to train two of them.
Yeah, you can train only one component that gets the steps I did, what I've just learned, the tools and the goal, and to output the next actions I want to do in code, free text, whatever. And planner is just a specific case with the empty state of the thing that I've done and the thing that I learned. You just start for empty states, tools, and goal. What do I need to do?
Because you did nothing and you learned nothing.
Yeah, when you start.
So essentially, you're training a replanner, but some of your examples there include the empty state.
That's true.
And some of them are not. And that's how you can actually just use one component for all the planning process.
Yeah, that's true. We utilize it in two different places in the system.
And hopefully it works good, right?
It works great and it's generalized well between those two tasks.
But how do you know? Like, how do you know that it works well?
So you need evaluation for every tool or thing you do in machine learning and deep learning and AI agents.
And here it's even harder.
Yeah, because you have a lot of moving parts. You have the planner and you have the tools and you have other things that goes in the environment that move between runs or even when you do the evaluation. And there are no specific ways to just evaluating the planner because we said that there are very different formats for plans.
But you can evaluate the planner and the execution engine. And there is a name for that, by the way?
AI agent, maybe.
But no, but just
the system, yeah.
The system? Do you want to coin the term?
No.
No?
I'm not responsible for namings here.
You're not that good at namings, I remember. Okay, so we said you can evaluate both of them, or do you need more specific tools, or how do you?
Yeah, so we're going to evaluate end-to-end approach, okay, which means we start from instruction and the final answer, and then all this system goes as a candidate to this evaluation. So one very popular benchmark here is the Gaia benchmark. It was introduced 2 years ago, was released by Hugging Face and Meta, FAIR, Facebook AI research.
Mayor? Or is there still FAIR?
I don't know. Again, I'm not here for the namings. And it consists of around 500 questions written by humans, which are mostly information retrieval and combining from multiple data sources to answer a specific goal. And they're pretty esoteric. Most of the questions there.
Do you maybe have an example?
Yeah, it's like, okay, in this side, there is on the right an image. In the image, there are 2 astronauts. So the one which is a bit higher, how many minutes did he spend on the moon?
How many?
I don't know, but super esoteric, but it's a good proxy for other tasks, for example, like what is the revenue of the most successful automotive company?
It kind of seemed a bit unfair because I can take the same planner and execution and just switch the tools maybe and get a better result. Or the entire end-to-end system, maybe this planner and execution engine is much better, but it's missing 2 of the tools that the other system has.
Yeah.
So how can you actually know?
Yeah, so the input for the system is tools and instruction. This is what AI agent gets. So if we want to check only the planners, we can fix the tools to be the same in all setups and just change the planners and the execution engines between them. And this is the way how we compare those systems head to head and to be apples to apples.
Apples to apples.
Yeah.
So you mentioned Gaia. Any other benchmarks?
Yeah, so there are more. Gaia is the most popular. I think it's nice to mention another one, which is the agent bench, which is kind of similar, which means there are initial goal and final answer. But in agent bench, the difference is that you need to interact with the environment. You do action that change the environment, like deleting rows from database or moving some mails to archive. So you start from specific environment, your agent does what it does, and then you check that the environment is in the desired state. And this is the way the setup of this evaluation, which is also very promising area of agents that actually does something in the world.
Do we see correlation between agents in Agent Bench and agents in Gaia, or they're not even related?
So I think the interesting phenomenon here is that the closed source models families, when you change them to open source, you see a degradation in results. So we see a gap between those models, and I think we see it across all
the board.
assets. Yeah.
Okay, so just to make sure, maybe if I'm evaluating a planner, I'm going to these benchmarks. Is that enough, or any other? How did you figure out if it's good?
So those are very general benchmark. If you want to solve specific tasks with your specific task distribution, you probably need to craft your own data set. And this way you can compare different approaches, whether it's React, whether it's Planner.
So I can use those benchmarks to kind of gauge the quality, but again, there's no replacement.
They are very general and not sure that they are a good proxy for your use case.
So there is no replacement for testing on my data, my use case.
Always.
Let's put aside the evaluation part and maybe go a bit before. Let's say that I'm now in the state that I choose to use a planner.
Mm-hmm.
Why? Because my React framework didn't work as well, and I've heard this podcast, and you convinced me that planner is all I need. How to use it?
So I think this is kind of a very practical question. How those things we just talked about relates to my use case or my day-to-day. And I believe that you always need to start from a simple solution, whether it's React or other, but make some POC, proof of concept of product that solves your use case, and see the results if you encounter a quality issue, or you see that your task could be paralleled and you gain some latency improvements. Those are good signals that you want to consider using planners. This way or another, I suggest not to craft your own planner by hand. Use the frameworks. There are frameworks like Hugging Face, like LangChain, AutoGen, Maestro by A21. All of them can bring you a lot of value with low effort to start and experiment with those planner-based agents and see the results. And I think this is a good takeaway.
And maybe just to summarize the motivation for planners. What are the cases where we'll need a planner?
Yeah, so it relates to the initial motivation and the advantages we talked about. Whether it's something related to your product that you want to reflect to the user what you're going to do, whether it's something that your tasks could be paralleled in some way and you can gain latency improvement, or you see that your task is too complex and you think that breaking down the task would help the agent to solve it. And the last thing is the concept of multi-agents, whether you want to utilize this delegation of work between different styles of agents and LLMs, it's also a good signal to use.
Okay, Nitzan, let's wrap this episode up. I'm going to ask you a series of questions. Just answer, don't overthink it. When do I use an AI planner?
So we said quality, latency, and human in the loop.
Cool. How does planning look like?
You can have free text and code.
Any tips for building an AI planner?
So one, start from simple solution, and the second one is use existing frameworks.
What type of frameworks do we have?
You can use LangChain, Hugging Face, Small Agents, and the A21 Maestro, of course.
Thank you very much, Nitzan. It's been a great pleasure having you here.
Thank you for having me.
And stay tuned for next episodes.